recording
All right, so for horizontal asymptotes, what you're going to do is you're going to use these three rules that we learned yesterday. So if it's balanced, that means that the exponents are the same. Then we're going to take the coefficients, set them over each other, and simplify. So this is going to be 5 over 1, which is just going to simplify down to 5. So for our horizontal asymptote for number 1, it's going to be y equals 5. What? So looking at the exponents, if they're the same, that means they're balanced. We're going to have 5 over 1, which is the coefficients, because this is saying take the coefficients of the highest power, which is 5 over 1. Okay. I do not. All right, so now we're going to look at example 2. We've got exponents 1 and then 2 in the denominator. So this is going to be bottom heavy, okay? So what it means is our horizontal asymptote is going to be y equals 0. We are using those three rules, okay? So our exponents are the same, so that means that they're balanced. That means that we're going to use the coefficients out front. So that's going to be 3 over 5. So y is going to equal 3 over 5. Somebody asked me if you could put that as a decimal. Yeah, absolutely you can. But I would probably see it written more as 3 over 5. Yeah. Okay. On number 2, if we look at our exponents, we've got 1 in the numerator and 2 in the denominator. So this is going to be bottom heavy. So y is going to equal 0. All right, so this is on the front of page 5. So what's going to happen is we're going to factor the top and we're going to factor the bottom. So in the top, we're going to factor and we're going to get a times c is going to give us -6. Our b value is going to be 1. So what two numbers will make that happen? 3 and -2. Okay? So when we factor, we're going to do a times c. That's going to give us -6. Our b is going to be 1. What two numbers will make that happen? 3 and -2. So I can write that top as x plus 3 times x minus 2. In the bottom, we're going to factor as well. So we're going to do a times c, which is going to give me 3. My b is going to be 4. What two numbers will make that happen? 1 and 3. So if I write that out in factored form, it's going to be x plus 3 times x plus 1. Identifying the whole is where we're going to cancel out in the top and the bottom. Okay, so this x plus 3 repeats in the top and the bottom. So what we're going to do is we're going to set that equal to 0, solve, and we're going to have a whole at x equals -3. All right, so in the top part of 3, if you factor this, you're going to get a times c, which is -24, and b, which is 2. What two numbers will make that happen? We will. We will in just a second. How did I get -24? I said 12 times -12. 2 times -12. Okay? So your a times c gives you -24, and your b is 2. Okay? So now what we're going to do is we're going to say what two numbers, if I multiply them, I get -24. Add together, I get 2. That's 4, -4, and 6. So now I'm going to use the box method because the coefficient is bigger than 1. So the coefficient for this one is bigger than 1. So we're going to write the first term in the first box, last term in the last box, and these two numbers that I just found, I'm going to slap an X onto them and write them inside the box. The first has to go here, last has to go here, and these two doesn't matter. You can switch them. Okay? So now what we're going to do is we're going to take the greatest common factor from the rows and the columns. So if I look down this way, it's going to be 2x, right? If I look down this way, I'm going to get -4. If I go by this row right here in the first row, I'm going to have x. And if I have the row this way, I'm going to have 6. Nope, 3. Sorry. Okay, and here's the reason why I got those numbers. When you check this, what you need to look for is that this number times this number gives you what's inside that box. Okay? This number times this number gives you what's inside that box. So you have to make sure all of those line up, otherwise you're going to get the wrong answer. So if I write this out in factored form, I'm going to have 2x minus 4 times x plus 3. And in this denominator, we have x squared plus 3x. The only thing that these two have in common is an x. So if I divide everything by x, I'm going to get x plus 3. Okay, as we can see, there's a repeat in the top and the bottom. So what's going to happen is I'm going to set those equal to 0 and solve. And that's going to give me a whole at x equals -3. Okay, on this first one up at the top, they all have an x in those terms. So we're going to pull out an x in the top. And we're going to be left over with x squared minus 3x minus 4. Okay, so now we're going to actually factor this stuff in that parentheses since it's a quadratic. Why did I pull out an x? Because all of these terms had an x on them. So we want to turn it into a quadratic so that we can factor them. So we're going to do the x method. So we're going to take our a times c term, and that's going to give us -4. Our b is going to give us -3. So what two numbers will make that happen? -4 and 1. So I can rewrite this top expression like this. X times x minus 4 times x plus 1. In this bottom piece, we notice that they both have an x. So we're going to pull out an x, and we're left over with this. But can I factor what's inside that parentheses? Yes. So I'm going to use the big X method. What's a times c? -1. There is no b term here. So we're going to have 0 in the bottom. What two numbers will make that happen? -1 and +1. So this bottom piece could be rewritten as x times x plus 1 times x minus 1. We're going to notice that we can cancel some stuff out, right? These x plus 1s can cancel out. So that means that I'm going to have x equal -1. And these x's are also going to cancel out. If I set x equal to 0 and I solve, guess what I'm going to get? 0. So my holes are going to be located at x equals -1 and x equals 0. So again, this isn't in your packet, but I want to make sure that you got some practice on it. It's been a minute since we've seen this. All right, so it says Ron rode 8 miles on his bike in the same amount of time it took Harmony to ride 6 miles. Ron rides his bike at a rate of 4 miles per hour faster than Harmony. How fast was Harmony riding on her bike? So this isn't in your packet. This is just practice that we're going to go over. So what you're going to do is you're first going to identify the fact that x is going to equal the speed of Harmony. Okay, so how fast Harmony was going. Okay, so we're going to set up a proportion. Okay, and how we're going to do that is we're going to say, well, Harmony was riding at 6 miles, like she rode 6 miles total, over how fast she was going. Well, we don't know how fast she was going. That's what we're trying to solve for, so it's going to be x. And we're going to set that equal to Ron rode 8 miles, and he was riding at x plus 4 miles per hour. Okay, and the reason why we say x plus 4 is because he was riding 4 miles per hour faster than Harmony. Okay, so that is how we're going to set up this proportion. What we're going to do now is we're going to cross multiply, and that's going to give me 8x equals 6x plus 24. So I cross multiplied. This is what I get. If I solve for x, I'm going to subtract 6x from both sides. And that'll give me 2x equals 24. I'm going to divide by 2. And so x is going to equal 12. So she was riding at 12 miles per hour. So on this one, again, this is not in your packet, but on this one, a passenger jet flew from Atlanta to Miami, so that's 650 miles in the same time it took a propeller plane to fly from Atlanta to Savannah. The jet was flying at a rate of 400 miles per hour faster than the propeller plane. How fast was the propeller plane flying? Okay, so the first thing that I want to do is I want to set up a proportion. So on the left-hand side, we're going to talk about the jet. And the jet flew 650 miles, right? Right? In the bottom part, we're trying to figure out how fast it was actually going. Okay? The jet was flying at x plus 400 miles per hour, faster than the propeller plane. Hey, Jordan. Thank you. Okay? So we're going to set that equal to the propeller plane, which that flew 250 miles, and we're going to put that over x, because x is going to represent how fast the propeller plane was going. So when you cross multiply, you would get 650x is equal to 250 times x plus 400. If I were to solve this out, I would get 650x equals 250x plus 100,000. If I'm trying to get x by itself, I'm going to subtract 250 from both sides. So this will be 400x equals 100,000. I'm going to divide by 400 on both sides. Ooh, yikes, yikes, yikes. So x is going to equal 250 miles per hour.